and then I'm going to give Linda a little introduction. So today we have Linda Jones, PT, PhD, presenting. She has been working in spinal cord injury for over 20 years. After focusing on physical therapy intervention in the intensive care unit, she managed the first cell-based trial in spinal cord injury, followed by the first study utilizing cell derived from embryonic stem cells in the United States. She subsequently joined the Craig H. Nielsen Foundation, managing the translational research portfolio, as well as initiating and overseeing special projects. She is a member of the Spinal Cord Injury Outcomes Partnership Endeavor, the chair of the research committee of the American Spinal Cord Injury Association, and she has served on the National Institute of Neurological Disorders and Stroke Elements for Spinal Cord Injury Committee. Her interests lie in clinical trial design, outcome measures, and bridging gaps between preclinical and clinical research. Currently, she is leading an effort to better understand the gaps between animal and human outcome measures. Today, she will be presenting on a rodent-human sensorimotor outcomes matrix, overlaps and gaps. So without further ado, turning it over to Linda.
Thanks, Erica. Now that you've given the introduction, I realize I do need to update my my profile. Okay, so I'm guessing that my screens are switched and I need to switch the display settings. Is that right? Am I in the right mode or not?
It doesn't look like you're in the presentation mode yet.
There we go. That should be right there. Okay. So as Erica mentioned, I'm going to talk about rodent-human sensorimotor outcomes, overlaps and gaps. And I'd like to start off by saying that this work was sponsored by this department, actually, Thomas Jefferson University, Office of the Provost, and the Center for Outcomes and Measurement. So we are really grateful to the center for sponsoring this really important work. So this is a slide I added about 1 minute ago. So it's not my favorite map of Ireland, but with 1 minute to go, it was the best I could do. And I added this to tell a story, which is that I was in Ireland attending ISCOS and had a little social side trip to Galway, and with some good friends and colleagues who I will not name, but we were sitting down to dinner, and one of them is a preclinical researcher and one of them is a clinical researcher. And the preclinical researcher said, "Hey, I've just had this really interesting finding in my lab." And the clinical researcher said, "That's great, but I wouldn't put that in humans. I wouldn't do that to my patients, at least not with the information you have available to you now." And I think what that really, and the picture on the right is the restaurant we were in, which was a lovely, lovely restaurant. And what that really highlighted to me and all of us at the table is the need for communication between preclinical and clinical researchers. And partly as a result of that effort and with the inspiration of MJ, we initiated this effort to really look at where outcomes align and where they don't. So when we wanted to do that with bench to bedside translation. And as you all know, this is the Center for Outcomes. The basis for determining recovery and effectiveness of an intervention is related to our outcomes and endpoints. So we wanted to focus on outcomes at this point. There's been a lot of information published about differences in models, you know, hetero versus homogeneity, et cetera, but we chose to focus on outcome measures. And as mentioned, it's the key to understanding the impact of our research. And we have to consider where in the spectrum our outcome measure is assessing. Is it at the level of body function and structure or impairment, or at the level of function? And we need to consider whether our outcome measure addresses recovery versus compensation. And just to note that in the field of spinal cord injury, there are no, quote, qualified measures for spinal cord injury. And in part, that's because we haven't actually had a successful phase 3 trial in spinal cord injury where something is actually recommended for use. And in addition, as you all well know, we have to consider the construct that we're measuring, the psychometric rigor, endpoints, effect size, and clinical meaningfulness when we apply an outcome measure in either human or animal studies. So the objectives of this work were, again, we focused on sensory motor outcome measures and the alignment in preclinical and clinical outcome measures. And we really wanted to understand the differences and the similarities and where they align, and if so, how they align. And our goal was really to promote a better understanding of outcomes of animal and human research studies, to appreciate the implications when one is translating, and to encourage bi-directional communication, as I had in this restaurant in Ireland. Now, if we could all be so lucky to have those conversations at a really nice restaurant in Ireland, that would be fantastic. So our methods were, we used expert small group consensus, and I'll show you the group in a minute or two. We focused on sensory motor outcomes just to limit the scope of what we were looking at so that it was something manageable. And we approached each outcome assessment by the construct that it measured versus the specifics of the measure. So what was the underlying construct that the measure was assessing? And then we separated our groups into upper extremity or upper limb, lower extremity and lower limb groups. And we focused clinically on the most common outcome measures. So we focused on outcome measures that are noted within the NINDS common data elements for spinal cord injury. And we did the same for animal outcome measures, the most common. We don't have NINDS CDEs for animal measures yet, although it's something that they're working on. And what we did was we identified what are the animal measures that we wish to look at first. And then we said, what's the human equivalent? And then we did the opposite. We said, okay, what are the human outcome measures and what's the animal equivalent? And then we kind of mashed it together to see where things lined up and where they didn't, and identified the gaps and overlap. So this is our crew. And as you can see here, hopefully you can see my pointer, it's a mixture of preclinical and clinical researchers. So MJ is a clinical researcher, Kareem Fawad is a preclinical researcher, I'm a clinical researcher, Adelfield Fote is a clinical researcher, Michelle Bassa wears two hats. She works in the preclinical and clinical space. David Magnuson is a preclinical researcher, as is Veronica Tom, and they had different expertise in their world. So this was our small group. And as mentioned, we looked at human to animal and animal to human translation, and then put it all together. And I just want to, you'll see this, graphic again, but I wanted to just orient you to it and to what we did. So this is our lower extremity graphic. And on the bottom, we go from lower levels of function, so no walking function, to independent walking. And then here we look at spinal cord injury. So in other words, severity of spinal cord injury and walking function. And the lines here indicate where on the spectrum a given measure functions. So as an example, this yellow line represents myotomal strength testing, which can be assessed with very low levels of function. And you can see here other things we looked at. So this green line is walking ability as assessed by SCIM and WSKI, the neuromuscular recovery scale here, et cetera, et cetera. And if you go down to the dark green line here, this is looking at distance. So this, as indicated by where the green line starts, would be somebody, this is appropriate for someone who's already walking with assistance, and it can really go all the way along the spectrum to independent walking. So this was kind of our framework as illustrated by human lower extremity function. And then here's an example of rodent. Ignore the red lines, I'm going to get to those. But similarly, on the left side, no hind limb movements to walking movements with plantar stepping. And we did that in the upper limb and in the lower limb. And these are just sort of our overlying how we looked at things as an idea. So now I'm going to jump into some of our comparisons in the lower limb. And I'd like to first acknowledge Adelfield Fote. This presentation that I'm giving today is an amalgamation of a presentation we gave at Asia. And so I've pulled slides from the different presenters, and the section that I'm about to present was provided by Adelfield Fote. So humans and rats share some basic features of locomotion. In both species, CPGs probably play an important role. However, the need for supraspinal input to the CPG or central pattern generator is likely greater in humans, but there are definitely some similarities. So obviously there are some differences when we look at the anatomy, the limb anatomy between a rodent paw and a human foot. And the limb mechanics differ. And this is an example here of limb mechanics in a rodent versus a human and how they may differ. Rodent walking characteristics are relatively constant, although there are some times when they are not. Whereas in humans, we have a capacity for a wide range of kinematics, where we might walk differently on a day like today, a Monday, versus a Wednesday versus a Friday, where we're pretty psyched to enter the weekend. Kinematics can be captured in rodents and in humans, as we know. And so that's one area where we may have some alignment, is in kinematics and how they're applied in animal and human species. But, you know, there are differences with humans. For example, in humans, when you use a device, it changes the kinematics. And this is illustrated here by the image on the right, where this person may be using a walker, which completely changes the kinematic profile. And we don't have that in the rodent model. So again, you've seen this slide. This is really looking at some of our lower extremity outcome measures, and I oriented to you to where there's no walking function to independent walking. And as mentioned on the right side, we looked at very commonly assessed measures. And I just want to point out, and I think this becomes even more important with upper limb, that one of our commonly used outcome measures is myotomal strength testing, as assessed by the International Standards for Neurological Classification, otherwise known as INSCI. And so this is something that's very commonly used. A couple other things that are quite commonly used in outcomes in the lower extremity are speed walked, ambulation speed, and distance walked. And these are quite common in humans. But when we get to rodents, we see that there isn't actually, it's not common in the rodent and lower extremities that there's myotomal strength testing. In fact, I would say it's quite difficult, a little different in forelimb. And in terms of distance, that also is not commonly assessed in a rodent model. And I won't go into a great deal of detail here, but you can see where there's sort of a lightning rod, but there's not a great equivalent in the rodent species. So for example, there's no great ability to assess walking ability without compensation in the rodent model. The typical tools that are used do allow for compensation, whereas in humans, we can actually use tools that account for compensation. So where are there some aspects of outcomes in the lower limb that line up? So, and when I say line up, I would say there are some analogous features. So the BBB, or the Beatty-Bresnahan-Basso scale, was a scale, one of the first scales used in rodents to assess locomotion. And it's a 21-point scale, and it is the most commonly used scale for rodent outcome measures. And a 0 has no observable hind limb movement. A 10 has occasional weight-supported plantar steps with no forelimb hind limb coordination. And a 21 is what we would call a typical gait pattern in a rodent, with coordination, consistent movement, appropriate paw placement, trunk stability, etc. So this is a scale that is the most commonly used scale in the rodent model, at least in rats. And there is an analogous measure in mice. And in humans, we have the SciFi that was developed by Adelfield Bote, which is a 20-point scale. And some of the criteria within this scale are similar in terms of weight shift, foot contact, etc. So there are some areas of alignment between these two measures, as an example. So to summarize overlap and dissonance between lower limb measures, the spinal level control is similar. The addition of rehab training is possible in humans or in animals. And interlimb coordination is an important feature of control in both rodents and humans. And there's some matching of outcome measures that's possible to better understand the links between humans and rodents. One is kinematics, and another, as an example, is BBB and sci-fi. However, some of the differences are that humans are more dependent on supraspinal input to the spinal circuits during locomotion, and some aspects of walking cannot or are typically not addressed in rodents, such as hind limb strength, distance, speed, and the use of compensatory devices. So now going into some of the upper limb comparisons. And in this section, this was covered by Kareem Fouad at Asia. So these slides are courtesy of Kareem. And you can see here the anatomy of a rodent forepaw and a human hand. And so why even, why even look at the relationship between animals and humans? Well, in 2002, Armin Kerr published a publication pointing out the difference in that rats have no opposable thumbs. And while that is true, rats are capable of grasping food pellets with a single paw and can adjust their grasp patterns to accommodate for pellet size. So if you go back to the first photo here, you can see that although they don't have an opposable thumb as we do, they do have the ability to use their digit in an opposable manner. So there are some similarities, but it's not quite the same. Quadrupeds don't use forelimb as much for handling objects as humans do. And as we know, rodents rarely wear a shirt with buttons. So when we begin to compare some of the outcome measures, as in animals and humans, we need to consider floor and ceiling effects based on severity of injury, which we do. And this is a summary, again, as mentioned, this is the equivalent summary in upper limb function, where on your left you have no function and on the right neurotypical function. And these are measures that we would typically use to assess in humans. So myotomal strength testing, which I would say is very commonly used as an upper extremity outcome measure, or I should say an outcome measure in trials of cervical spinal cord injury. We have aspects of SCIM, such as feeding, bathing, and grooming, which focus on the upper limb. The neuromuscular recovery scale. We also have the QT developed by Ralph Marino, et cetera, and the GRASP, which is also assesses upper limb function, but really focuses on the hand. And we do have kinematics for the upper limb, although they aren't that commonly used clinically. So looking at the animal model to create a forelimb dysfunction is a created model as opposed to in humans, in order to just impact forelimb function without creating a high level cervical spinal cord injury where one would have a symmetrical lesion, because it's difficult to maintain animals with that type of a lesion, and there are ethical considerations. So the type of lesion used in the animal model is different than what we would find in humans, but does still create a loss of forelimb function to assess interventions and apply outcome measures. And these unilateral lesions produce deficits in paw and wrist function. And on the left, you can see that this animal is unable to open their paw. And further, the image, whoops, on the right, this animal is unable to extend their paw. So what are some common outcome measures in animals and humans? Well, one is kinematics, and we discussed this in the lower extremity. Kinematics are not commonly used in forelimb function for rodents either, but this is an area where we could have some alignment. And what you see here actually is an animal doing a single pellet grasp function, looking at kinematics during that activity. And this is an example of single pellet grasping, which is a very commonly used measure in rodents to look at how quickly they grasp a pellet and how frequently. And again, kinematics can be overlaid on that. In the single pellet grasping, the animal is able to use compensatory movements depending on how the task is set up. As opposed to an activity called the Montoya staircase, which you can see here, the rodent is actually asked to grab a pellet off the stair, and it minimizes their ability to use a compensatory strategy. So in this activity, a rodent is much less able to use a compensatory strategy. So we really do get more recovery versus compensation with this activity. However, as mentioned in the lower extremity, we don't have a great equivalent for myotomal strength testing. Now, on the right, you'll see an activity where the rodent is pulling on a bar. There's also a rope pull task where the rodent might use their forelimbs. But this isn't really discrete myotomal testing. It's really more upper limb function. There's a reflex component to it as well. Another activity that has some overlap with human outcomes assessment is the Fruit Loop task, which is one of the few bimanual tasks that's assessed in rodents, where the animal has to grab a Fruit Loop and handle that with as a bimanual task. There's another test called the pasta test, where the animal gets increasing strengths of pasta that it has to break. And so that relates to strength. But again, it's not discrete myotomal testing. And as you well know, looking at upper extremity motor scores is a very common, and neurologic level of injury is a very common outcome measure in human spinal cord injury studies. So what are the pros and cons in looking at fore and hind limb function and comparisons between animals and humans? The model that's used in animals is straightforward and ethical, but it doesn't precisely mimic the model that we have in humans. We do have precision reaching in both in animals and rodents. And we have some outcome measures that match, others that do not. And within some of these outcome measures, we can get good resolution of function. The addition of rehab training is possible, as with the lower extremity. And for some of the outcome measures, compensation can be addressed. Some of the cons of the animal model are that the tracks are somewhat different, and reaching is not as well developed a skill in a rodent as it is in a human. So what are the applications of all of this information that we've kind of aggregated? What do we do with this information? So one goal for us is really to promote an understanding of the literature. And I'm using here a similar example to one that I used earlier, which is the Basso-Beatty-Bresnahan scale and the sci-fi. And what we really hope to facilitate within the field is that when you're planning a human study, that you understand the preclinical literature and the outcome measures that informed your work. So what animal work has been done prior to you planning an animal study, planning a human study, and what are the outcomes that were used, and how can you best align with those outcomes? And on the opposite side, when you're planning a preclinical study, to understand the human outcome measures. So what's the next step in the translation of the work that you wish to do? And what are the outcome measures that might be used when something is assessed in the clinic? And we really want to understand each other. So we want to have early bidirectional communication. And I gave the example earlier where, at dinner, there was an understanding that something that was done in one person's lab, the clinician might have a concern with. So what we'd really like to encourage is that someone like MJ would say, I'm planning this human study. I need to call Kareem before I design this study. I need to understand what preceded the work that I wish to do, let's say as an example in the forelimb or the upper extremity in humans. And conversely, we'd like to encourage people like Kareem and other preclinical researchers to call, whoops, I didn't change the name here because the last presentation it was Adele, but I need to call MJ before I design this preclinical study. So I need to understand, after I complete my preclinical study, how is MJ going to look at this clinically? What outcome measures has she going to use? And how can I best align these outcome measures? Another thing that we need to think about, and we don't have answers for this at all, is clinical significance. So with the given therapeutic in animals, does a clinically significant change in animals mean there will be a clinically significant change in humans? And the illustrative example here, again, is the BBB, the Basso-Beatty-Bresnahan scale. And in the BBB, this change from between sort of 8 to 10 is a really pivotal area of change where you start to get plantar placing in the animal. And so this is, I I would say, considered to be significant, a significant change in the animal population. How does that equate to a significant change in humans? And can the response in animals inform the target population in humans? So in looking at our animal studies, does that also tell us, who should we be assessing this in? What should our inclusion-exclusion criteria be? In other words, if it works with a certain type of injury model in an animal, is that what we should be looking at in humans as well? We also want to gain a better understanding of predictive power. So which outcomes in rodents and humans are predictive for recovery? So an example might be kinematics. So if one were to be developing a human research study and wanted to understand the difference between doses of a given medication, you might use kinematics to see if there's a difference in dosing in kinematics, because kinematics are a bit more sensitive than some of our functional and behavioral outcome measures. And could we do the same in rodents? Is this something that we could carry through from looking at rodents, dose range finding in rodents, to humans? And would that be helpful in planning our studies? We also want to think about safety and efficacy. We talk a lot about safety a lot about efficacy and where our models overlap, but we also need to consider safety. So within human outcome measure assessment in a spinal cord injury study, we often use INSTI, which I mentioned earlier, looking at motor and sensory function. And we use that scale not only to look at efficacy, but also for safety. So if there's a deterioration in function, that's important information about the risks of the therapeutic. And is this something that can be emulated in the animal model, where we can also use changes in some of these outcome measures to determine if there's been deterioration? And this is particularly important in the forelimb because, as we all know, loss of upper extremity function has a significant clinical impact to individuals living with spinal cord injury. So a few takeaways here. The development and assessment of measures differs in preclinical versus clinical communities. So as you well know, being part of the Center for Outcomes Research, the reliability and validity and establishment of those psychometrics is really, really critical in the human population. And in fact, if you don't have this established, then you would not be able to use the outcome measure as an endpoint in a clinical trial, or as an outcome measure and an endpoint in a clinical trial. But in the animal community, it's a little bit less rigorous in terms of assessment of reliability and validity. And often for our animal measures, an individual in a preclinical study may take those animal measures and they may change them a bit to suit exactly what they're looking for. In humans, we can't do that unless there's validation of that change. As mentioned earlier, in humans, a common outcome measure is motor score or strength and our neurological injury and walking distance. And in animals, this is not a common measure. So is there a way to use existing animal measures to better assess strength, or do we need further development? We mentioned some areas of alignment with walking ability and gait, and there are more than this. This is just the illustrative example. But we do think that some of the key opportunities are in functional outcomes, gait, and kinematics. And what are those opportunities and how can we better align them? And as mentioned, as an example, we really need to consider the differences in animal and human function, where humans need fine motor function for dressing, et cetera, whereas in rodents, they don't dress. So their activities are different. And so how do we understand that alignment? I mean, if we even look at SCIM in terms of the activities of, self-care and grooming, et cetera, where do these measures line up in animals and humans, and where do they not line up? And what are the next steps? So once we've identified the gaps and similarities, how can we improve study designs? So can we use existing measures that may reflect bidirectional translational outcomes? Could we modify existing measures to better reflect bidirectional translation and validate the use of those measures in that fashion? Is there any value to developing new, more analogous measures? I think none of us really wants to develop new outcome measures because, as this group well knows, developing new measures is a very laborious, time-consuming, and extremely costly process if done well. So, that wouldn't be our first choice, but we do need to consider, what do we have at hand that we can use? Can we use it better? And if not, do we need to do something different? Are there advanced analytical methods that might help us better understand the gaps and overlaps? So the last time I spoke to this group, I spoke about the FIM-SCIM crosswalk that I created for my dissertation. And I used a more advanced statistical methodology based on item response theory called Roche analysis. And this is a more advanced method to really understand an outcome measure. Can these analytical methods be used to help us better understand the gaps and the overlap in our human and animal measures? Would principal components analysis, as an example, be a tool that we could use to better understand how these measures overlap and how they don't? And in our group, we didn't get to that point. We were just kind of looking at them on paper, but this is something that we'd like to explore in the future, especially given that we have these large databases that are being aggregated predominantly in the preclinical world, but those databases are also adding clinical data to their data sets. And one I should mention here is the Open Data Commons for spinal cord injury that is being run by Adam Ferguson out of UCSF. And they are taking human data into that data set. So if you have any human data, that we really want to push getting more human data into that data set. Right now, it's predominantly animal data, but using some advanced analytical methods in our large data sets, using existing data, could that help us better understand our outcome measures? So what are the ultimate deliverables? Well, we intend to publish the upper extremity and lower extremity matrix between animals and humans, so kind of the grids that I showed you earlier. We also want to address some larger issues in terms of how outcomes are developed and assessed, and the models that we use and how they differ in animals and humans and how that affects our outcome measures. We want a clear understanding of the alignment between clinical and preclinical measures in terms of the underlying construct being assessed, and we've kind of made a stab in that direction. And we really hope that this will improve the flow and clarity of bench to bedside and bedside to bench research and really increase communication. Because, and one challenge is when you look at even the centers that really focus on spinal cord injury research, often they'll have this really strong clinical group. They may not have a preclinical group, or vice versa. At Jefferson, you have a strong clinical group and you have some preclinical researchers. You also have a strong preclinical group at Drexel. And could we facilitate more communication between those groups? And at least you have strong groups in the same metropolitan area, others do not. So how can we really bring people together to start having a conversation when planning a study? And could this work also contribute to overall common data element endeavors? I mentioned that there are no common data elements in animals, although that is underway. So could this understanding of alignment contribute to those efforts? And in talking about the deliverables, I think you can see that the top deliverable is publications of the upper and lower extremity matrix. And so I am responsible for those publications, and I have been branded with the Scarlet P because I have not yet completed those publications, analogous to the Scarlet Letter. So I need to get on it. Every time we present, we get more information, more feedback from the community, which is really helpful, but we need to publish them. And until I publish them, I have to wear the Scarlet P every time I present in front of this group. In fact, here's my Scarlet notebook that I often, when I'm presenting at this group, I have to put in front of me until I get those publications out. So those are our next
very
steps.
good.
Those are our next steps. And now I would love to have further discussion, questions, comments, things that might actually help us contribute to that publication when it is complete. Any questions or comments? MJ, you've got to have a question. Come on.
Well, I mean, I'm holding off for other people. I mean, this is the third time we've done this presentation about, right? I think it gets tweaked every time it's presented.
It does. I'd actually be curious, Ralph, to see what your comments are, having spent a lot of time developing human outcome measures. I don't
Yeah,
mean to call you out.
I was
but-
waiting for a comment from Ralph and perhaps Misha, and I know Stephen Kern's on who does some development of measures. So I'm just curious about those who are doing it. I know Nicole and Rachel are also on who are in the middle of developing a new measure.
I think it's a bit difficult, especially with upper extremity and the differences with rodents. I don't know if it'd be better going up into like primates, although that gets then very expensive. Much more difficult to conduct those studies. I'd have to think more of is there a different approach in humans that would sort of align better with the rodent outcome measures. Yeah, I can't see suspending a person on a ladder and making them reach down for
A pellet.
a food or a remote something.
Yeah.
And
And I
Ralph,
think,
I was just gonna add, Ralph, I think we've had the conversation about your measure, the QT, and I know we've had it about the measure we're developing about, are we able to somehow use very low profile, almost seamless instrumentation to collect some kinematics? So very low profile, seamless instrumentation on those objects to really look at the kinematics of, hand placement. Are they using the fingers, just et cetera. So I think that's a potential opportunity in the future.
Right. Yes.
and I think, Ralph, your point about the primate model is a good one. We focused on rodents because that's the most common model. But I think you're absolutely correct that if one does use a large animal model, particularly a non-human primate model, that there may be more analogous measures. I think that the non-human primate field also suffers from challenges in their outcome measures. I don't know it as well, but even within those large animal models, there are challenges with having a well-designed and accepted outcome measure. But to your point, I think a non-human primate model would certainly be closer to the animal model. Although that's not always indicated in a given study because of cost and ethical concerns. But I think another thing that I didn't bring up, which is just kind of occurring to me as I'm speaking with you all, is the use of devices to track. My words are evading me right now, but to use sensors to track activities that individuals are doing at home. And so looking at, let's say, how often is someone using reach and grasp in the home, and what is the quality of that movement? And perhaps that's something that, as that field is still really in development, but as that field develops, is that something that we could use commonly between animals and humans? I don't know, just kind of posing a question.
I think that's a great idea. I think that actually is a good way to bridge the two. We do have these tools now that we got from Dr. Klasko's support to have people go home and wear various sensors of various levels of fidelity. And I think that by tracking those kinematics of the limb and posture, and then doing it both naturalistically when they're at home, but also when they're actually sitting with the OT-PT doing certain tasks, will actually help us unify the animal and human data. I mean, the problem, I did a lot of non-human macaque work, and the problem is, while they have upper extremity movements that are much more human-like than a rat for sure, they're very overtrained. They're not necessarily natural. And there's no easy way to measure anything akin to the kind of function that a therapist is going to care about. I mean, you can, they have tried. I mean, I have a colleague at Chicago who lets them sort of run around their cage and tries to, and uses motion tracking with cameras to sort of track, you know, their more normal grooming behaviors, and that's somewhat more akin. But at least in the field of brain-computer interfaces for people with spinal cord injury and stroke, a lot of the metrics they use are so basic that they become a very noisy measure relative to day-to-day function. I think this is a really tough thing to bridge. It's not obvious to me, and I think maybe just the key is to try to collect both types a lot together and then sort of curate them and sort of make sense. Because I don't know. I mean, I haven't seen much literature like that. So, you know, on the Cordimo trial that we're trying to publish now, this is exactly the concern that came back. They're like, okay, you have all this high-tech neural data and you have EMG position, and then but you're using these old-fashioned, outdated OT measures, and like, how dare you? And part of me is thinking, well, good point. We want to validate it. My other thing is that that's because the OT and PT measures were built around what was concrete and functional, and all these other things about weird limb angles. It's like, who cares? You can have two patients who have identical limb angles, and one's very functional and one isn't. So they're obviously not perfect. So I think this is I don't know. I think your deliverables and goals are very noble, because this is sort of an unknown, unbrokered area. So
I think noble equals almost impossible, but but I think just having the conversation is a good place to start, because it doesn't typically happen. I also think, to your point, I don't know how many of you on the call have used item response theory or a type of item response theory, Roche analysis, but I think that in the animal world, that has not been used. I would venture to say at all. That's probably extreme, but extremely rarely. So the BBB scale that I presented, that 21-point animal scale that looks for locomotion in rodents, that has not been subjected to a Roche analysis. So what we don't understand is the difference, and it is an ordinal measure. So for sure, the difference between a 2 and a 3 is not the same as between an 8 and 9. But we really don't understand that measure in terms of, do we need 21 points? Is a 13 actually more difficult or easier? Or I should say, does the 13 reflect more function than a 10? We haven't done that in our animal measures. And in our human measures, I would venture to say we haven't done enough of it either. And I'm really looking forward to Ralph using an item response theory analysis for the QT. No pressure there, Ralph.
Well,
I've
mine,
looked at that a little bit. I'd have to go back to that. Again, you need more numbers to be able to do that. So we need a lot of data.
You could probably do it with, it depends. It depends on your spread, but as little as 100, but it would depend on the range of function. So anyway, just a little poke there.
Ralph, that may be a good thing to consider if sponsors allow it after the close of trials to get their data set to run some IRT on the data they're collecting with your measure.
Right. That would be good.
That's a
Linda,
great
Put that
idea.
into the license agreement. You could put that in.
We could put that in, that we would like access to de-identified data at the close of the study for this exact purpose. I mean, that's a really good idea to put it in the licensing.
And you can de-identify the allocation, the group allocation, so it has nothing to do with the intervention. Because if you were to do a Roche analysis, it would not matter at all whether an individual received the intervention or not, because that wouldn't be the point. I think that's
Ralph,
a great idea.
We could definitely do that. I just wrote that down. Linda, I think an important point of this whole work also is, bi-directionally, as human researchers, appreciating what preclinical outcome measures and preclinical results can tell us and cannot tell us, and vice versa. So, I think that, historically there's been this all or nothing position, perhaps more not among researchers, but clinicians that, oh, this worked in the animal model, let's move it to humans. But, appreciating what works in humans and how that was measured in the construct that was measured, and how that fits into our human reality of people and, like you said, models of spinal cord injury, complexity of the human being, the construct. And I think if we just open up the dialogue of what is known, what we can use and what we cannot use, and go, have that conversation is very important.
Mhm.
And I want to follow up on something that Linda asked about perhaps having sensors on people in their homes. My work is in the patient's natural environment, and our typical population are patients who have reached the limits of conventional rehab. And I think that it could be very, very interesting to do kind of focused studies of someone doing a particular activity in the home, because people behave differently in the home than they do in the clinic. And oftentimes they have come up with some pretty clever workarounds for their limitations. And I think, I think that might be worth, that might be something that's worth exploring.
And I think sensor technology is improving in the animal world too. I think it's used in a different way typically than in the human world, but I think that considering that area of potential alignment could be important. That being said, and just thinking about it, the rat is not in their natural environment. They're in a caged environment, so it isn't the same as being at home. But if you had, and I'm just talking out loud here, I haven't thought about this at all, but let's say you had a rat in an enriched environment where they had more than what's available to them in a typical cage, then you might see a little bit more degrees of freedom in terms of what they do and what they choose to do, more similar to what an individual person might choose to do in their home environment. I don't know, I'm just talking out loud, but.
Yeah, I mean, Laura Carissa, that was the topic of her PhD dissertation, looking at enriched environments in the preclinical models of the upper limb also. But Misha, maybe this issue, this idea of sensor technology and looking at function in natural environments, we could talk about, it'd be a great postdoc opportunity at Jefferson, in my opinion, having someone spend 2 to 3 years really helping develop that expertise and some focus around it.
Yeah, I agree. I mean, the technology is only getting better and more widespread. I mean, you can get a bunch of Apple AirTags for next to nothing. Tag every darn thing in the environment. Wall-mounted sensors, LiDAR. You could, in the setting of the study, you could do a ton of things. And to Linda's point about starting with, again, I'm naive and not an expert like you guys on outcomes and all these item analyses and statistics that are like, look a little bit Rube Goldberg to me. But I think that if there are scales and that are uncontroversial and validated, that rather than telling the animal people to duplicate that in a sort of what's going to probably be pretty arbitrary, use those metrics in a clinic and a home setting, and like I said, wire the heck out of them. Just like sense everything, and then let the machine learning help start relaying it to the animal stuff, because it may not be obvious, and we're probably going to make the incorrect assumptions about what links to what. And my guess is we'll probably be surprised. But there may be some human analogs to some weird rat forepaw thing, like Ralph said on the ladder, is just like whatever. And also those kind of rubrics also may give you just may yield more useful statistics, I think, than just totally a random fishing expedition. But anyway, but yeah, MJ, I totally agree. We would love to
Well,
sensorize.
yeah, and what's cool is, Elliot's here and he's already, providing interventions in home environments and is looking for a way to create more robust measures to look at outcomes, right, Elliot? In the naturalistic environment.
Well, the advantage of working, actually, the advantage of working in the natural environment when you work with people's actual activities is that you're able to come up with ecological validity. It is something that someone is doing in the real world. You have to be able to demonstrate that they couldn't do it before, and now they can, and you have to have an intervention that plausibly can explain why you're getting the outcomes that you do, which generally are pretty easy to do. My problem is how do you collect the successes of an individual and come up with a scale of either disability or what I much prefer is competence in their everyday lives, and be able to link that to subjective quality of life. And your crew seems to be very well very good at measuring these in between and partial successes in the non-natural environment, and the question is, how can we then translate it into a more holistic evaluation of the individual?
Yeah. Yeah, so much opportunity.
I'm also wondering, it's too bad Dan's not on the call, but one thing I've been thinking about that I really need some expert weigh-in on is, could we use, I mentioned item response there and rationalysis. So one thing I mentioned that tells you on an ordinal scale is also how difficult a particular item is. So it linearizes the measure on a logit scale and tells you relative to 0 how difficult the item is. And I wonder if we were to do that, let's say as an example for the BBB and the sci-fi scale, would it tell us which activities within those measures have equal levels of difficulty in an animal and a human? And would that just in and of itself help us better understand the measures? And I'm not sure if you can do that. You can do it. I'm not sure if it is a valid comparison, but it's something I'm intrigued by and would like to talk to statisticians about, because even like you can understand the measures independently and just see, how difficult is it for a human to have, proper dorsiflexion in locomotion, and compare that to something in an animal model. I don't know if that would be valid, but I'm intrigued by the idea of it.
I'm wondering how you can do that with something like the BBB, which really is one item. So you can't it's one item with a bunch of levels. It's not like the FIM that you're looking at,
Right.
13 different items and then looking at how difficult is each item. Each item has an ordinal ranking of 5 points or something. And the BBB is one item with 21 levels. So you may be able to do something with that, but I haven't seen it done with a single item, looking at whether there's inversions or whatever in the profile. It may be possible. Then like way over my statistical head.
But I think, again, not being familiar with all the measures in too much detail that you're talking about, it seems if the goal is to increase ecological validity and understand sort of durable outcomes I mean, it seems to me part of it is just to do it, is to sort of do data gathering and like, you know, video and record sensors or whatever, and then have like Ralph and Linda and MJ like sit and look at these things and look at how BBB or FIM, whatever particular tasks are. Of course, it's not going to be accurate because it's not going to have such distinct start and end points. It's not going to be someone saying go, stop now. But I think that kind of supervision of it is going to be more valuable than just letting the statistics, I don't know, go by themselves, I guess. I don't know. I think a trained eye will be able to start pulling things out. And you know, there is a precedent for this, right? I mean, what's her name? John Beebe with mother-child infant interactions, where they have these poor, miserable postdocs spending like by the microsecond watching the videos and rating it, and then in the insect behavior, like hormones and fruit flies, and you know, the computer vision tracks these things. But there is a rubric to get at this naturalistic stuff, and I think what you're going to have is you're going to basically be able to replay. Okay, let's you know, the person has a spinal cord injury. They're trying to open. You know, now they're in their wheelchair. They're going up to the door. How are they going to do this? So now you have a sensor on the door. You have the kinematics of their hand, and you guys are thinking, because you understand. You're thinking, okay, if this person was in the clinic, or if they were in a clinical trial sponsored by NIH or NIDLR, this is how we would assess it. And so now, and you can replay this. You can have a little avatar of the person as they're reaching and get their trajectory and all the EMG synergies across the joints and all that stuff. And you can slow it down and say, okay, this naturalistic piece, we're going to annotate it like this. And I think that will start to bring it together. But I don't know, I'm just rambling. So
I
That's
like
some
when
good
you ramble,
rambling.
Nisha. Yep,
Right.
it's good. It's fun to hear.
Yeah.
All right, well, this is sorry, Elliot, go ahead.
No, one of the problems of working in the natural environment has to do with privacy and people's and people's behavior that they may not want you to see, but there may be ways of getting around some of it. You know, the good idea, the idea about having sensors that, if, particularly for physical things, which my area is cognitive functioning, so I see physical as being so much easier because you can go from a neuron to a muscle. Not quite as easy if you want to study problem solving. One of the interesting things might be to do a serial study and take someone who has some accommodations, new accommodations, and see what they're able to do weeks and a month or two or maybe three later with the technology, and how they've been able to fashion the technology's functions to solve problems that they have. And some of that involves really unanticipated uses of things that you have designed, and all of a sudden you're saying, wow, where did that come from? And that's really terrific.
Yeah.
And that's something that could be done with both animal models and with people. You mentioned animals in a cage and animals in enhanced environments, but you know, to that animal, that is their natural environment. So you may be able, and it's a natural environment. It's a simple environment, and you can do studies of lower extremities and upper extremities and see how a particular animal responds to it.
Yeah.
This has
Yeah.
been such a great discussion. I love when these lectures result in great discussion. So Linda, thank you so much.
Thanks, everybody. Good to see some new people, and good to see people I know as well. And thank you for this opportunity.
We'll wait for that publication. We'll wait for that publication.
Publications. Huh.
Yes.
All
All
right.
right.
Well, thanks,
Thanks,
everyone. Have a
everyone.
great day. Bye-bye.
Thank
Thanks.
you.